In this video, I'll show you 4 examples on how to use the Pythagorean theorem. Let's start with a little theory. In a right triangle, the side opposite the right angle is called the hypotenuse. And usually the right angle of a triangle is represented by a square. And the other two sides are called legs. So this side right here and this side are called legs, and we usually label them A and B. The legs and the hypotenuse are related to the Pythagorean theorem. Starting with question 1, we're asked, find the length of the hypotenuse. Round your answer to the nearest tenth. That being said, this right here is our 90-degree angle, so we'll call it C, and this side opposite to C will be called little c. This will be called little a and b. It doesn't matter which one you label A and B, but the most important one is C. Let's write the Pythagorean theorem. A squared plus b squared is equal to c squared. 3.3 to the power of 2 plus 4.2 to the power of 2 is equal to c squared. What we have to do from here is find the answer on the left side of this equation and then square root. Here's what I mean. 3.3 to the power of 2 plus 4.2 to the power of 2. Just found the answer to the left side. Square root both sides. If I square root the number that I just found, I end up with 5.34. Notice that when we square rooted the number, the square here disappeared. So square rooting eliminates the square. And remember, we need to round our answer to the nearest tenth. This means that we will stop writing after that 4. Our answer is 5.3. The 4 is less than a 5, so we leave it as a 3. Moving on to question 2. Find the length of the missing side. Round your answer to the nearest tenth. Now this time, unlike before, we are given C. C is the hypotenuse, and it's right across the 90-degree angle. This can be either A or B, really doesn't matter. Let's call it A. Using the formula, a squared plus b squared is equal to c squared. Let's substitute A into our formula. Plus b squared is equal to 19 squared. Now some students have a hard time isolating for b, have a hard time solving for it. And many will simply memorize b squared is equal to c squared minus a squared. Instead of having to memorize this version of the Pythagorean theorem, you can simply evaluate 10 to the power of 2 and evaluate 19 to the power of 2 and subtract them. Essentially, it's the same thing as this. So here's what I mean. 19 to the power of 2 is 361 minus 10 to the power of 2. We square root both sides now, and we end up with 16.15. B is equal to 16.15. Something you should be aware of, the hypotenuse is the longest side of a right angle. 16.15 fits this triangle because it's less than 19. So that should give you an idea of whether you got the right answer. Once again, we're going to round to the nearest tenth. Given that this 5 is the last number, we will have to round this 1 to a 2. 16.2 is equal to B. If your number is 5 or more, then you usually round up. Although it gets more complicated when you start to consider significant figures. But if you're in grade 9, it really doesn't matter. Just use the fact that if it's a 5, it goes up. In question 3, we're asked to calculate the area this time of a triangular sail on this toy sailboat. The area of a triangle is base times height divided by 2. Luckily for us, we already have the height, which is 7, but we don't have the base. So I'll put a question mark for B. To find the base, we can use the Pythagorean theorem. A squared plus b squared is equal to c squared. And I'm going to give you a second to figure out what your c is, because that's the most important part. Your c should be this line, because it's across the 90-degree. Now let's input all the values we know. We know what c is. It's 10, so 10 to the power of 2. This can represent A or B. Let's call it A. Doesn't matter which one you use. And we will isolate for B by finding the answer to this and subtracting it to 7 to the power of 2. So technically, if we were to do some algebra here, we would move this number over to the other side, that would make it negative. Let's go ahead. We have 100, I know that's 100, minus 49, 7 to the power of 2 is 49, and we square root. Click answer for the previous number that you found. We get 7.14. B is equal to 7.14. Let's round this to the nearest tenth just because we want to be consistent. Let's use 7.1, and this will represent our base of the triangle which we need to find the area of. 7.1, your base, times your height, divided by 2. 7.1 times 7 divided by 2 gives us 24.85, and we will round to the nearest tenth. This 5 will make this 8 into a 9, 24.9. And since we are finding the area, this should be centimeters squared. In our last example, Alysia wants to determine how high her kite is flying. With the 125-meter string fully extended, she pulls the kite so that it is directly above the tree. She estimates the tree to be 85 meters from where she is standing. How high is the kite? Once again, we'll use the Pythagorean Theorem to find h. Our hypotenuse is 125, so we'll call this c squared. Our a value can be represented as 85. 85 squared, that's our a value, plus our b, which is what we're looking for. To find the answer to this, we'll take 125 squared, subtract it from 85 squared, so let's do that in real time, minus 85 squared, and we square root now, where we end up with 91.65. 91.65 is equal to b, and b represents the height. That is in meters, and we'll round up to the nearest tenth. Given that this is a 5, it becomes 91.7. And there you have it. 4 examples on how to use the Pythagorean theorem with right triangles.